Okay, so you might notice that in section 6.2, I skipped ahead and started with number 5. The reason why is number 5 is actually a much more easier, straightforward problem than number 4. So it's really best that we start out with number 5. Now, this is telling you in the problem, this is what we need to pay attention to, okay, is that it says here they give you an average, x bar, that's your mean. They give you a standard deviation, that's your sigma, okay? They tell you the variable is normally distributed, that's your z-score. Ta-da! So I'm going to be using the formula x minus x bar over sigma. How do you know? Well, I just kind of described it to you. They tell you it's normally distributed. They don't give me a sample size. I don't have anything else to go off of besides that, and I got an average and a standard deviation. So I'm going to be using that formula there, okay? Now, remember the default is less than. So if I'm trying to find the z, that they will make less than 60,000 a year, I just go ahead and plug in 60,000 for my test x, minus 50,000, my x bar, all over my standard deviation, which is 5,400. I punch that into a calculator, and my z is 1.85. I look that up in the back of the book on the chart, and I get 0.9678, and that's all I have to do to figure that one out, okay? The next one is asking me what is the probability that they will be paid between this much. I will subtract, but I have to find the z-score for it, okay? So I'm going to do this one, same formula, z equals 49,000 minus 50,000 all over 5,400, and I have the other one that is going to be 57,000 minus 50,000 all over 5,400. I'm going to get two z's. Okay, so this z for the very first one ends up being negative 0.19. You have to round. You get negative 0.185. Please round it or else it's not going to be correct. And then this one gets you 1.30. You look those up in the back, and you end up with the respective areas of, for the bigger one, 0.9032, and the smaller one, 0.4247, and you subtract them like we've done before, and you end up with 0.4785, and that is your answer, okay? The next one says an employee is paid more than this of his or her coworkers. How much is he or she paid? You're trying to find the minimum, okay? Minimum, what do you call, like, salary. So guess what we're missing? We're missing x. But they gave me the area. So the first thing I do is I take this and I make this adjustment. I need to look at my chart and find the z-score that goes along with this. Whenever I do that, I find out that z is equal to 0.4. I'm missing x. I have everything else, x bar and sigma. So I set it up like this. Okay? So I set up my formula like this, and I need to solve for x. So this is where Algebra Math 111 comes in handy. You have to multiply both sides by 5,400, whatever the denominator is, to get rid of it. And then from here, you're going to take x minus 50,000, and you're going to add it, so I'm going to take my 50,000 and add it to 2160, okay? That's what I get when I multiply 5,400 times 0.4. And I end up with an answer of $52,160. That's my x. So that is the minimum salary right here, that someone would make to be making more than 65.54% of their coworkers. Minimum salary. This is how you do it, okay? We're not trying to move mountains here. We just got to figure out how to do these problems. Now, this type of problem, what I just did by working it backwards, is how number 1 through 4 is at the beginning of this page. That's why I didn't want to start out with this. I wanted to show you the straightforward way to do it, and then we're going to go and do all the other ones like this. Now, let's go ahead and do that, okay? So if we look here, they give us the average is 65, and the standard deviation is 10. It is normally distributed, so I'm, again, using that same formula of x minus x bar all over sigma, okay? Here they tell you, what's the minimum score, just like we found the minimum salary, for someone to be in the top 15%. Well, this is done a little different. What I need to do is do 1 minus 0.15 to be in the top 15%, and I get 0.85. I look up what's the z-score that's closely associated to 0.85 without going over, and I find out that its z is equal to 1.03. Now, I take my formula and I set it equal to 1.03, and it's x minus 65 all over 10. And now I work backwards like we just did in that last example. Multiply by 10, multiply by 10, 10.3 is equal to x minus 65. Add your 65, and you should end up with x is equal to 75.3. So 75.3 is the minimum score the student would have to get to be in the top 15% of the test takers, okay? The next question says, it gives an A for everyone in the top 10%. If the student scores 85, does he or she get an A? Why or why not? Well, what we need to do is find what is the minimum score for the top 10%. The exact same one. Start out 1 minus 0.10. Gives me 0.90. Find the closest z to 0.90 without going over. In the back of your book, in the chart, it's 1.28, okay? Same formula, 1.28 is equal to x minus 65 all over 10. Multiply by 10, multiply by 10, you get 12.8 is equal to x minus 65. Add your 65 on over. I'm going to skip that step here. You get x is equal to 77.8. So if 77.8 is the minimum cutoff for top 10%, if the student has an 85, yes, they did get an A. The reason why, and I'm just going to tell you, not write it down, is that the minimum score is 77.8. The student got an 85. That's greater. Shows that they're in the top 10%, okay? Now the next one is asking, find the minimum and maximum test scores that lie in the middle 40% of the test scores. This is just like that one problem, middle 40%. Here we go. This is my standard curve. This is z equals 0. And then on this side, I have 40. And so each one of these is 0.20. So how do I do this? Remember, 0.20 plus 0.50 or 0.5 gives me 0.70. I look up in the back of my chart for the area that goes with 0.70, with closest without going over, and I end up with z is equal to 0.52. Now, remember, you get two answers here, a positive 0.52 and a negative 0.52, okay? So I'm going to do the same formula with these two things that I just found. So it would be 0.52 is equal to x minus 65 over 10, and negative 0.52 is equal to x minus 65 over 10. And I go through and I solve, and I'm going to skip that step here, okay? And you get 70.2 and 59.8. And so those are the two answers for the minimum and maximum scores. Now the last one. It says here, assume that for a student to fail the test, he or she must score in the lowest 5.48%. Find the test score corresponding. So again, I need to make this a decimal. If you're making this a decimal, you move it over twice, and that gives you 0.0548, okay? I find the z-score that's closely associated with this. It's going to be negative, so its z is equal to negative 1.6. I take that, and I set that equal to my same formula that I've been using here. Multiply both sides by 10, multiply both sides by 10, and I end up with negative 16 is equal to x minus 65, add 65, add 65, and I end up with 49 is equal to x. So the test score that corresponds to the cutoff for a failing grade is a 49.